So, question 5 from this paper, the differentiation question. The equation of a curve is y equals x squared ln 4x minus 3. Find the exact value of the second derivative at the point on the curve for which x equals 2. So it's basically saying differentiate it twice. But also this bit where it says find the exact value means it doesn't care too much about tidying up your derivatives. You just need to get to the end of it. So what have we got? Y equals x squared ln 4x minus 3. We recognise that as being a product. Two things multiplied together. And so we'll put into action what we've just written down. The product rule says this is the first, I'm not going to write out all the details of u and v, the first thing, which is x squared, times by the derivative of the second. And the second is a chain rule thing, it's a function of a function. So if we differentiate ln 4x minus 3, it's the derivative of the whole thing, Big Bear. I was tempted to roar at that point, but I wouldn't. So Big Bear would be the derivative of natural log of something is 1 over the something, multiplied by the derivative of the little bear in the inside bit, which is 4x minus 3. If you differentiate 4x minus 3, you get 4. So that's that bit done. That's u dv by dx plus the second, v, which is ln 4x minus 3, times by du by dx, which is 2x. And so it looks like that. Now we don't need to do too much, but I will tidy this up a little bit. We've got 4x squared over 4x minus 3 plus 2x times the natural log of 4x minus 3. Okay. Now the nightmare thing here is that if that isn't bad enough, we've now got to differentiate this again, because it said find d2y by dx squared. And first time we had to do a product rule differentiation, but now we're going to do a quotient rule and another product rule. So we're going to be really organised about how we do this. This is two separate terms now that we're differentiating. So as we go into the second derivative, one little thing just to point out, I know none of you would do this, but look, we've got 4x squared there and 4x minus 3. Don't feel tempted to cancel the 4, because we can't, can we? Because the 4 isn't a common factor. You can only cancel if it's a common factor at the top and bottom. Yeah, a few times doesn't matter. Right, so if we differentiate this again, we're now doing u over v. So it is, remember, oh no, which comes first? Is it v du or u dv? Visual display unit. v du by dx. Rubbish, isn't it? Sorry. Right, so this is v, so that's the bottom line, times du by dx, the derivative of the top, which would be 8x, minus the top, 4x squared, times the derivative of the bottom, which is 4, all divided by v squared. So that's done the quotient rule bit of that first term. Now the second term was 2x times ln 4x minus 3. That is a product rule thing that we're doing. So that is u dv by dx, so u times dv by dx. But hang on, we've already differentiated that once, haven't we? It was 4 over 4x minus 3 plus, on the next page, plus, so that's u dv by dx plus v times du by dx. So I'm multiplying that by 2, and then 4x minus 3 times 2. Now this question, the nice thing about this question is it doesn't expect you to show that this is any particular answer. It doesn't really want you to do anything with this. What we could do, all we're after is what this is equal to when x is 2. So we could at this point just sub x equals 2 into this and finish it off. Now, for my own peace of mind, I'd rather actually tidy this up a little bit first, just because then there'll be less chance of me making a mistake later. But it doesn't matter if you don't. What have we got? We've got, having said I'm going to tidy it up, I'm now regretting it. We've got 32x squared there, take away 16x squared. So I think we've got 16x squared minus 24x. So put it like that. Here we've got 8x over 4x minus 3 plus 2 natural log of 4x minus 3. Right, the question said, evaluate d2y by dx squared when x equals 2. So when x equals 2, this is, and now this is just a really careful bit of putting numbers into the calculator. What have we got? 16 times 2 squared, so that's 16 times 4. Or, yeah, really careful. This isn't 16 times 4 and then square it, is it? We couldn't do that. Okay, so it's 2 squared times 16, take away 24 times 2 over, what's this, 8, take away 3 is 5, squared is 25, plus 16 over 5, plus twice the natural log of 5 there. It did want the exact value, so that this bit we need to keep in terms of our natural log. If we tidy this up, we've got, what is this? This is 16 over 25 plus 80 over 25 plus 2 and then 5. So we've got 96 25ths plus 2 ln 5, although if you've ended up with ln 25 there, then that's fine, because that's the same thing. Did it say a particular form? Didn't it? Just said find the exact value. So there we go. We'll leave it like that. There we go. It wasn't a bad 8 marks. And if you think what we actually did there, if you really concentrate and are really organised with it, there's nothing horrific in there. The problem is, there's so many spaces to make a mistake, isn't there? And you miss, you do one daft thing at the first bit that you've done here, and then it just gets worse all the way through, and you end up without the right value at the end of it. So it's a case of being really, really careful, really concentrating on what you're doing, and do make use of the space. They gave you in the exam booklet, they gave you a full A4 page on which to do that. When I did it, I only used half of the space that they've given. But make sure that you lay things out really, really clearly. Take plenty of space to do it. Be really logical and answer it. Great.